Hi everyone, so today we're going to be taking up the Chapter 4 review questions, which are the suggested questions for studying for the test, which is tomorrow. So this is from page 250, number 2 to 3, and then 5 to 16. So number 2 says solve each equation using algebra. So we need to find what x equals. So 3x plus 6 equals 12. My goal is to get this x by itself. So what's stopping me from doing that is this 3 and the 6. So first I'm going to take away take away 6 from both sides, and I'm left with 3x equals 6. Then I'm going to divide both sides by 3, and I'm left with x equals 2, because these 3's cancel out here. So that was A. B is 5 minus 2x equals 11. So to get rid of this 5, I'm going to subtract 5 from both sides. So 5 minus 5 is 0, so it's negative 2x equals 11 minus 5 is 6. Divide both sides by negative 2. And now I have 6 divided by negative 2 is negative 3. C is 4x minus 8 equals 12. So I'm going to add 8 to both sides. So now I have 4x equals 20. Divide both sides by 4. And I'm left with x equals 5. D, negative 6x plus 8 equals negative 10. First I'm going to subtract 8 from both sides. So I have negative 6x equals negative 10 minus 8 is negative 18. Divide both sides by negative 6. And I'm left with x equals 3. Right, number 3. Determine the x-intercept of each of the following. So remember that the x-intercept happens when y equals 0, because that's when the line crosses the x-axis. At that point, y is equal to 0. So I'm going to plug 0 in for y. So A is y equals negative 5x plus 20. So if y equals 0, then I have 0 equals negative 5x plus 20. Now I need to get x by itself. So I need to first subtract 20 from both sides. So negative 20 equals negative 5x. Divide both sides by negative 5. And I have 4 equals x. So the x-intercept is 4. And as a coordinate point, that would be 4, 0. For B, 2x plus y equals 10. So same thing. For the x-intercept, y equals 0. So my goal is to get x by itself, but first I'm going to set y equal to 0. So 2x plus 0 equals 10. That just leaves me with 2x equals 10. Divide both sides by 2. So x equals 5. So the x-intercept is 5, 0. All right, skipping over to number 5. Solve each equation in question 1 using inverse operation. So looking back at the equations given to us in number 1, we have 4x minus 5 equals 3. So we want to solve for x. So inverse operations is BEDMAS backwards. So BEDMAS now becomes SAMDEB. So that means that first we're going to do the subtraction. So this is subtraction, addition, multiplication, division, exponents, brackets. So first the subtraction. So we're going to add 5 to both sides to get rid of that negative 5. So now we have 4x equals 3 plus 5, which is 8. And then we're going to do the division. Divide both sides by 4, because division is the opposite of multiplication, and that's how these two numbers are connected. So divide both sides by 4, I'm left with x equals 2. B is 1/2 x plus 3 equals 5. So first I'm going to take away 3 from both sides. So I'm left with 1/2 x equals 5 minus 3, which is 2. Then I need to get rid of this 2 here. The opposite of dividing by 2 is to multiply by 2. So now I'm left with 1x equals 4, which is the same as x equals 4. C is negative 2x minus 3 equals negative 4. So first I need to expand this out. Technically I don't have to, but it will make my life easier if I do. Negative 2x plus 6 equals negative 4. Now I'm going to subtract 6 from both sides. Negative 2x equals negative 10. Divide both sides by negative 2, and x equals 5. All right, I'm going to do D on the next page here. D, 1/4 equals x plus 2/5. Sorry, that's multiplied here. 1/4 multiplied times x plus 2/5 equals 0. So I'm going to expand. Now I have 1/4 x plus 1 times 2 is 2 over 4 times 5 is 20 equals 0. 2/20 is the same as 1/10. So I'm going to subtract 1/10 from both sides. 1/4 x equals 1/10, negative 1/10. In order to get rid of these fractions, I would use a common denominator, which could be 20. So this would be 20 times 1 divided by 4. So 20 divided by 4 is 5x equals 1 times 20 is, is 20 divided by 10 is 2. So it would be negative 2. Divide both sides by 5, and x equals negative 2/5. Number 6. Erin joins a CD club. The first 10 CDs are free, but after that she pays $15.95 for each CD she orders. A, write an expression for the cost of X CDs. So she pays $15.95, but she gets the first 10 free. So $15.95 times X is the number of CDs she gets, but that's X minus 10. So we can say the cost equals $15.95 times X minus 10. B says, how much would she pay for 15 CDs? So we're going to plug in 15 for X. So the cost equals $15.95 times 15 minus 10. So that equals $15.95 times 5, which equals $79.75. C, Erin receives her first order of CDs with a bill for $31.90. Create and solve an equation to determine how many she ordered. So we can go back to our original equation and plug in $31.90 for C. So $31.90 equals $15.95 times X minus 10. So we can divide both sides by $15.95. So $31.90 divided by $15.95 is 2. 2 equals X minus 10. Add 10 to both sides. 12 equals X. So therefore, she ordered 12 CDs. All right, number 7. Solve and verify each equation. A, 9x plus 2 equals 11x minus 10. So I want to get all the x's onto one side so that I can solve for x. So first I'm going to take away 9x from both sides. So now I'm left with 2 equals 11x minus 9x is 2x minus 10. And then I'm going to add 10 to both sides. 2 plus 10 is 12 equals 2x. Divide both sides by 2. And 6 equals x. B, negative 4/5 x plus 2/3 equals 1 3/4 x plus 2. So this one looks really confusing because it has a lot of fractions. But first we're going to get rid of the fractions. So common denominator of 5, 3, and 4 would be 60. And 1 3/4 as an improper fraction would be 4 plus 3 is 7/4. So I'm going to take each term and multiply it by 60. Negative 4/5 x so times 60 times 60 times 60. So negative 4 times 60 divided by 5 is negative 48 x plus 120/3 is 40 equals 105x plus 120. So now they're all whole numbers, so that's a lot easier to work with. Now I'm going to get all the x's onto one side by adding 48x to both sides. And that leaves me with 40 equals 105 plus 48 is 153x plus 120. And then I'm going to subtract 120 from both sides. And I'm left with negative 80 equals 153x. And then divide both sides by 153. And x equals negative 80 over 153, which can't be reduced. C. Negative 3 times x plus 1 minus 2 equals 4x minus 5 times x minus 3. So first I'm going to expand out, and I'm left with negative 3x minus 3 minus 2 equals 4x minus 5x plus 15. See what I did there? Okay, now I'm just going to combine like terms. So these ones are like terms and those ones are like terms. So now I'm left with negative 3x minus 5 minus x plus 15. I'm going to add x to both sides. So now I have negative 3 plus 1 is negative 2x minus 5 equals 15. I'm going to add 5 to both sides. Negative 2x equals 20. Divide both sides by negative 2. X equals negative 10. D. 4 plus x over 3 plus 4 equals x minus 6 over 2 minus 6. So again, I have fractions. I want to get rid of them. So in order to do that, I have to find the common denominator. So a common denominator of 3 and 2 would be 6. So I'm going to multiply each term by 6. So I'm left with, I can just actually cancel this out to be a 1 and a 2. So now I'm left with 8 plus 2x plus 24 equals, I'll cancel out again to be a 1 and a 3. So that would be 3x minus 18 and then minus 36. Now I have all whole numbers. I want to get all the x's on the same side, so I'm going to take away 2x from both sides. Now I'm left with 8 plus 24 would be 32. Sorry, not 3x, 32. Equals 3x minus 2x is x, and then negative 18 minus 36 is negative 54. Now I'm going to add 54 to both sides. And I have 86 equals x. All right, number 8. So the the area of a trapezoid is height over 2 times b1 plus b2. So the important thing to note here is that a trapezoid has two bases technically, so the top one is b1 and the bottom one is b2, or vice versa, but they use b1 and b2 because there's two different lengths that the bases are. Right, so in this case here, I have x plus 3 with a height of 4, and then I have 3x, 4x, and a height of 2. So I need to determine the length of the base, all four, so 1 base, 2 base, 3 base, 4 bases, if they have the same area. So the area of the first one, let's number them, 1 and 2. The area of the first one, 1, equals the height, which is 4, over 2, times base 1 plus base 2. So x plus 3 plus x. The area of the second one is the height, which is 2, over 2, not equals, but times base 1, which is 4x, plus base 2, which is 3x. Now, since their areas are equal, I can make these two equations equal to each other. So I have 4 over 2 times x plus 3 plus x equals 2 over 2 times 4x plus 3x. So now I'm just going to simplify this. So 4 divided by 2 is 2, and then x plus x is 2x plus 3 equals 2 divided by 2 is 1, and 4x plus 3x is 7x. So now I have 4x plus 6 equals 7x. Take away 4x from both sides. And now I have 6 equals 3x. Divide both sides by 3. And x equals 2. So I'm going to go back to my trapezoids. If the top of this one is x, then the top of this one is 2. If this bottom is x plus 3, then it would be 2 plus 3 because x is 2. So the base of that one is 5. And if the top of this one is 3x, that would be 3 times 2, which would be 6. And the bottom is 4x. That would be 4 times 2, which is 8. So those are my bases there. Okay, number 9. Is x equals 3 the solution to 5 times 3x minus 2 equals 4 minus 10x plus 1? Explain how you know. So we're going to take this x equals 3 and we're going to plug it in. Everywhere that there's an x, we're going to put a 3. So now I have 5 times 3 times 3 minus 2 equals 4 minus 10 times 3 plus 1. So first I'm going to do the brackets. So 5 times 9 minus 2 equals 4 minus 10 times 4 equals 5 times 7 equals 4 minus 40. 35 equals negative 36. No, it does not. So therefore, x equals 3 is not the solution. So if it was the solution, the left side would equal the right side. But since it doesn't, this is not a solution. Okay, number 10. Solve each equation for the variable indicated. So this means you just need to rearrange the equation so that the letter that they tell you is by itself on one side of the equation. So for A, I have perimeter equals 2L plus 2W, and they want me to get L by itself. So I'm going to take away 2W from both sides. P minus 2W equals 2L. and then I'm going to divide both sides by 2. So I'll have P over 2 minus 2 over 2, which is 1W. B, A equals P plus PRT, and then you just get T by itself. So first I'm going to subtract P from both sides. Now I'm left with A minus P equals PRT, and then I'm going to divide both sides by PR. So now I have T, this cancels out, T equals A minus P over PR. C, V equals pi r squared h. I need to get h by itself, so I just need to divide both sides by pi r squared. So now I have h equals v divided by pi r squared. And D, ax plus by equals c, and I need to get y by itself. So first I'm going to take away ax from both sides. So now I have by equals c minus ax, and then divide by b. Y equals c minus ax over b. All right, number 11. The formula c equals 5 over 9 F minus 32 is used to convert Fahrenheit temperatures to Celsius. A, determine the Celsius temperature when F equals 90. So I'm just going to take this equation and plug in 90 for F. So C equals 5 over 9, 90 minus 32. C equals 5 over 9, 90 minus 32 would be 58. So C equals 5 times 58 divided by 9, which would be 290 over 9, which is 32 2/9 degrees Celsius. B, solve for F in terms of C. So that means I want my equation to say F equals something with a C in there. So right now it's C equals 5 over 9 F minus 32. So first I'm going to divide by 5/9 because it's multiplied by 5/9. So that would be the same as multiplying by 9 over 5. So that would be 9 over 5c equals F minus 32. And then I'm going to add 32 to both sides. So now I have 9 over 5c plus 32 equals F. I don't know why I wrote that F backwards. So F equals 9 over 5c plus 32. Okay. And C, determine the Fahrenheit temperature when C equals 25. So I can actually use the equation I just made, or I can use the original one. I'll get the same answer, but I'm going to use the equation I made in B because it's going to be a lot simpler. So that was 9 over 5c plus 32 equals F. So I'm going to plug in 25 for C. So 9 over 5 times 25 plus 32 equals F. I can cancel this out to be a 1 and a 5. 9 times 5 is 45 plus 32 equals F. 45 and 32 is 77 degrees Fahrenheit. I wanted to do it again. Okay, number 12. Solve for y in terms of x. So again, that just means I need to make the equation look like y equals something with an x in it. So for A, 8x minus 4y equals 12. So I want to get y by itself. So first I'm going to subtract 8x from both sides. So now I have negative 4y equals 12 minus 8x divide both sides by -4, and I'm left with y equals 12 over -4 minus 8x over -4, which is 12 divided by -4 is -3. -8 divided by -4 is positive 2x. B, 5x equals 10y minus 20. Again, I want to get y by itself, so I'm going to add 20 to both sides. Now I have 5x plus 20 equals 10y, and then divide both sides by 10. I'm left with 5x over 10 plus 20 over 10 equals y. 5 over 10 is the same as 1/2 x, and 20 over 10 is the same as 2. C, 3x minus 3y minus 9 equals 0. This time I'm actually going to add the 3y, because I only have to move one thing instead of moving two. So now I have 3x minus 9 equals 3y. Divide both sides by 3. Now I have 3 over 3x minus 9 over 3 equals y. 3 over 3 is the same as 1x minus 9 over 3, which is the same as 3, equals y. And D, x over 4 plus y over 8 equals 2. I want to get rid of these fractions because I don't like to work with fractions. So I'm going to find the common denominator. The common denominator of 4 and 8 is 8. So I'm going to multiply each term by 8. Now I'm left with 8x over 4 plus 8y over 8 equals 16. 8 over 4 is the same as 2x, and 8 over 8 is the same as 1y equals 16. Now my goal is to get y by itself, so I'm going to subtract 2x from both sides. So now I have y equals 16 minus 2x. All right, number 13. Josh has $32 in loonies and toonies. Write a linear equation expressing the total amount of money in terms of the numbers in loonies and toonies. So we have $32 equals x plus 2y, where x is the number of loonies and y is the number of toonies. B, write an equation to express the number of toonies in terms of the number of loonies. So I have 32 equals x plus 2y. I'm going to subtract x from both sides. 32 minus x equals 2y, and then divide both sides by 2. Now I have 32 over 2 minus x over 2. So 16 minus 1/2 x equals y. C, use your equation to determine the 4 different possible combinations of coins Josh could have. So for this one, you could just choose different numbers. So if you could choose how many loonies he had, or you could choose how many toonies he had. So say he had 6 loonies, then you would just plug in 6 for x. So 16 equals 6 minus 2 equals x. 16 minus 8 equals x. 8 equals x. Sorry, 6 minus 2 is 3, not 8. So he had 6 loonies and 13 toonies. And then you could just choose some more amounts and see where you got. Okay, I'm going to continue this in the next video because I can only video 30 minutes, so there will be a part 2.